week 7 of 8, I believe. So just one more week. Before I get started, and to give everyone a chance to get here, are there any remaining questions from what we did last week, which was the dual machine shop engine? Everyone was good with the assembly?
I have a question about what we're doing today. Are we doing the keychain thing that you mentioned last week?
Yeah, we're gonna start designing a little keychain. I'll talk a little bit about 3D printing first, and then I'll do like a couple demos, and I'll give you some time to work on design of your choosing. So if there's no questions about this, we'll put it behind us and move on to our last topic for this class, which is 3D printing. So before I start, I'll start with a disclaimer that I'm not much of an expert when it comes to 3D printing. I don't run like a lot of hobby 3D printing type of stuff, but I do know a little bit. I have some experience, so I'll just share what I know with you and hopefully give you some resources where you can start to learn for yourself a lot more about how to use 3D printing, how to print stuff, things like that. Hopefully most of you do or will at some point have access to a 3D printer, either through like the AOE program or from your own schools. I know these days, probably even like in middle school, you might have like a tech shop that has, or like a class that lets you 3D print stuff, especially as the technology becomes a lot more accessible to people. In fact, you might even have like your own 3D printer. There's a lot of models of like hobby printing stuff that's pretty affordable just for a regular person. So a lot of opportunities that you yourself will probably have when it comes to this kind of stuff. So if you remember what I was talking about last week, I talked a bit about conventional manufacturing. So if you're manufacturing something like this, like little machine shop engine, the intent there, the reason people made those drawings was for people to, make this in like a typical machine shop, a place that has like tools like mills and lathes, bandsaws, drill presses, maybe like a laser cutter or a water jet. Just using these conventional tools to make these parts that we modeled out of materials like metal or wood. And kind of as a distinction, what we talked about last week is that there's kind of this subtractive conventional manufacturing, and we have additive manufacturing. And so with 3D printing, that's really what we're going to be talking about today. The idea of additive manufacturing, where instead of cutting material, instead of removing material from a big chunk of raw material, you're instead adding just the material that you want, layer by layer in this case, to kind of build up to your final part geometry. So we'll talk a bit about some factors that you need to keep in mind when you're 3D printing. Although the printers are pretty amazing, the computers do a lot of work, but there still is some thinking and planning, some engineering that you need to do on your end to make sure that the actual print is successful. There's a lot of bad ways to print things depending on the application. So it's good to think about these things and know that the considerations exist. So as a hobby printer, one of the first things might be aesthetics. So if you're interested in printing because you want to make little models or keychains or trinkets, things like that, that is a really big appeal of 3D printers, because a lot of the times they're little, just no matter what you're doing, there's something cool that you can make, like little small pieces of plastic, right? So in that case, aesthetics is probably one of your big concerns. You want to make sure that the printed part looks good. It's not rough, that you can't see like the adhesion lines too much. You're just trying to make something that looks good and feels good. So in cases like that, you're trying to do things like minimize the amount of support material you need, try to minimize the extent that you can see the individual layers. Now, if you're trying to print something that's a bit more practical, I know when I was about your age in middle school, I used 3D printing for the first time to make a nose cone for a model rocket. And so in cases like that, you kind of care a bit about the mechanical properties. If you're making anything for like a model plane or a model rocket, you might care about the smoothness of the surface. That's kind of similar to aesthetics, but you kind of want to make sure that it's low friction, right? The air. The other big thing is mechanical strength. So you want to make sure that the parts are strong enough to support whatever weight or withstand whatever loads that are going to be put on it. So, for example, you're making a part for a robot, you need to make sure that part's not going to break when the robot is moving around really fast, or if the robot gets hit by a ball, you need to make sure the printed parts don't fail. And this one kind of covers everything, but there's a lot of ways that 3D printers don't work the way that they were designed to. If you've ever had to set up a 3D printer, you probably had a lot of experience with things not working the way they're supposed to, whether on the computer end or mechanically. For example, a pretty common one is like spaghettifying. So the nozzle isn't getting, the extrusion tip isn't getting hot enough. So the adhesion, the layers don't stick together. So you're just basically streaming out plastic material without actually building it onto your part. So even if you search for something like failed 3D prints, you can see a lot of these examples where people just end up creating a mess because something was wrong with your printer probably, or you know, maybe their bed wasn't heated for that first layer adhesion. All right. So when it comes to printing, you kind of care a lot about your first layer. If your first layer turns out bad for some reason, it can potentially lead to the failure of the entire print. So it's a good idea to make sure that this goes well, just because it's the thing that everything else is going to be built on. So when you start a 3D print, you're going to end up using a program that's called a slicer. So your starting point, let's say, is a completed CAD model of a single part. And you know how to make that in Onshape. So you can export that as some kind of file, usually the .stl file format. And you'll import that model file into a program that's called a slicer. And this program will give you a lot of tools to set up how you want the 3D printer to make your part. For example, how the model is going to be oriented, where it's going to be located on the printer bed, like how finely to print the part, how much to fill in like the solid volume of the part, things like that. So for example, one control that you have is over the orientation of your part. So probably a good idea there is to make sure that you have a nice big flat surface, so that you have a good first layer on which everything else can be built. There's also these things called rafts. You can see it in the picture. These are kind of parts. It's something that your 3D printer will create that's not actually part of your desired part geometry. It needs to be removed in like a post-processing step, but it'll improve the quality of the actual part that you want because it's being printed onto a layer of plastic instead of the bed itself. Some other things, a lot of the concern if you're trying to print a lot of things or you need something done quickly is the printing time. One consideration that's not, like to me, it's not something I would have guessed immediately, but in most cases, the 3D printer will lay down material faster when it's going in the XY direction. So kind of on the horizontal plane compared to in the vertical direction. So if you have like a long rod, for example, it's going to print way faster if you have the rod lying down instead of having it standing straight up, just because it does less movement in the Z, like the total time it spends going up, adding new layers vertically is smaller if you have it lying down. So again, that's another orientation consideration. You just want to have a sensible way to position your part in the slicer program to make sure your print finishes quickly in addition to finishing successfully. Surface finish, if you've ever seen a 3D printed part, I'm guessing you have, but if you have not, for most 3D printers that you'll use, like fused deposition modeling, where you're just melting like a spool of plastic through a nozzle, what you'll find is that the final part will kind of have these striations, these lines that are left behind just by the nature of how the part was created, right? Since you're laying down material one layer at a time, at the end, when you look at it, you're going to see each of those layers in your final part faces. These like stripes that you can see, those come from every layer that you deposit on the part. So I guess the notable thing here, you might have better results if you try to get those, for example, with curved surfaces, you kind of want to lay those down while you're moving in the XY, in the horizontal plane, rather than in the Z plane. So if you have like a cylinder, your surface is going to look and feel nicer if you have it standing up as opposed to lying down at its side, because you're going to be creating the curved surface just based on the motion of the printing head, as opposed to relying on your Z layers, which are usually a bit less precise. More considerations. As you print more complex things, almost always you're going to have a case where you have some material that's unsupported, meaning that if you have it oriented just sitting on its plate, there's going to be overhang. There are going to be things that do not have material directly under it. And in cases like that, strictly speaking, you can't actually print something on nothing. If you have like a big overhanging flange, there's no way to actually print that, because when you're doing that first overhanging layer, there's nothing for the plastic to be supported by. It'll just fall straight down. So that won't work. In practice, you can actually do a little bit of that. But the print quality does tend to be lower on that unsupported layer. So one thing slicer programs will allow you to do is generate this supporting geometry. So again, this is kind of like the raft, where it's not something that you designed. It's not part of your original desired geometry, but it's something that's added by the program and that the printer will create to make the actual parts you want look better when it comes out. So you might have something like this support beam, and that just helps you achieve this overhang a lot better. So as a rule of thumb, if you have something that's more dramatic than like 45 degrees, you probably want to have some kind of extra support there. And things like the support materials or the rafts, generally after you finish printing the part and you take it off the table, you would break it off with like pliers or cutting tools, and then you'd just refinish that surface by sanding it or something like that. Maybe remelting it if you, depending on what you're doing. All right. Now, as I said at the beginning, one of your concerns with printing stuff might be making sure that it's actually strong enough to meet whatever loading situations that it's going to encounter. So to some extent, this is done in your geometry, right? Last week we talked about analysis, like you might do a simulation or do some calculations by hand to figure out if your actual design, just your pure geometry, is that strong enough to do what it needs to do. And you might have a geometry that's serviceable, but if you choose your print orientation poorly, then it might cause that design to fail because it introduces additional weakness compared to the base material, just because of the way that it's deposited layer by layer. So a printed piece of material is probably going to be weaker along those layer planes, just because those layers can separate, right? It's going to be weaker when you're trying to pull apart the layers as opposed to when you're trying to pull apart the actual strands of the material itself. You can kind of think of it like wood if you're experienced with how wood works, right? If you're pulling a beam of wood that's cut along the grain, then you're kind of, it's really hard to break. But if you're pulling a beam that was cut across the grain, it's a lot easier to break just because the material itself inherently is made up of layers that are attached together. And that attachment is weaker than the actual base material itself. So this is something you can control, again, with orientation. So you can kind of see that orienting your part is a pretty important step in the process, something you should think about. This consideration is mainly important, again, if you're using like if you're trying to make like a functional part. Most likely, in your case, this is something like designing a robot. If you're making brackets or some kind of fastener out of a 3D printed part, you're going to want to be careful that you choose a good orientation. So I said a lot of things here, but what you should know, what you should really take away from this is that there are a number of considerations that will affect how good your part is going to be. And there's a lot of resources out there that can help you do this kind of thing. The Slicer program probably has a lot of built-in like tooltips or help to help you figure out like how to do things, right? And at this point, there is a ton of resources. A few weeks ago, we talked about these like online communities, like Thingiverse. There's a lot of people out there who are experienced with the type of 3D printing that you will probably be doing. So there's a lot of material that's been generated for that purpose. If you just look up like 3D printing guides, there's a lot of material, and it's probably presented better than I could present it right here in this like 30-minute talk. So to get you started, here's like one link that I thought is pretty good in terms of explaining the concepts that I was talking about. I'll paste it in the chat for you there, but this is just one of many online guides that are out there that do a great job of explaining different things that you should think about. So like this is what I was saying, for example, about curved surfaces. They'll look a lot smoother if you print them standing up rather than lying down. And you kind of see also here the layer lines that are in the final part finish. Yeah, so when you have a minute, sometime, scroll through this, try looking for other things yourself. I think next week we might talk a bit about slicers. I can get a bit more into that, but most of the ideas, the things you need to think about are in here. So you don't have any questions about 3D printing, you can try my best to answer them. If you have any specific questions, you might be better off asking the person who is in charge of the 3D printer, or like the manual or an online guide or such, but let me know if you have any questions. If not, we'll move on. I'll introduce our last project, which I guess I told you about last week. It's going to be our Keychain project. So we're just going to have you each design a simple keychain, just something, maybe you don't even have keys, but if you do have keys, you know, like a little key ring, and you might have something or other little trinket to put on there. So design is entirely up to you. You can do whatever you want. If you do want to print it, I'm not sure this year what the situation is at with AOE, but if you have your own printer or something, probably keep it at a reasonable size. Like don't make it a foot long, because that probably, if you can find a printer with a bed and travel sufficient to print that, it'll probably take a full day to run, and a ton of material too. So just make it like reasonably small in case you ever do decide to get it printed. But otherwise, it's pretty much free for you to decide. There are a few more considerations that I'll go over next week, things like minimum like part width and things like that. There are some limitations to what 3D printers can do, as great as they are. It might be related to the specific 3D printer that you have, but I'll talk more about that next week. For now, I'll just do, I think, a couple quick demos, just give you guys a few more tools to help you design something. So for the first demo, I'll introduce to you a new sketch tool, which allows you to easily model text. So just like usual, I create my sketch, and what I can do here, there's a tool, looks like the uppercase letter A, and it's called the text tool. And it kind of works like the 2-point rectangle. We'll let you drag out rectangle. And when you do that, it allows you to type in a text of your choice. So just say, hello world. There's a few font options. You can also make it bold or italic and mirrored in either axis. You can see when you hit the check mark, it'll generate a sketch of the text that you typed in. So we now have a big hello world in our sketch. And I can adjust the size of it by dragging the blue points around. You can kind of treat it just like any other sketch entity. You can dimension it. So that's pretty useful if you care about the size, which you probably do. And once you give it a dimension, like the font and everything is kind of preset. So everything becomes fully constrained once you dimension the box. So you have a sketch something like this. And then you can do typical things that you can do with any other sketch entity. For example, I can extrude the text. Now you can see have a 3D body for each of these letters. If you're wondering why they all turn different colors, this is something I may have briefly said when we were talking about importing things. But what we have going on here is a multi-body part. So we're in a single part studio, but there are multiple solid bodies that are in this part studio. So I believe it was week 4 when I imported the shaft collar. There were the 2 C-shaped halves of the collar, and then there were screws that went through the C's to join them together. So that part was actually a 4-part. There were 4 separate objects that were in a single part studio. So if I had not chosen to combine them, they would have also by default come in as different colors just to represent that we have multiple bodies here. And the way that you can tell that there are multiple bodies is just if you look on your left side of the screen underneath your feature tree, you can see Onshape calls them parts, but you can see that I actually have 10 distinct parts. So it probably won't affect most of what you're doing, but there are times when it can be, there are times when it can make things perhaps unintended happen. For example, if you have a feature that extends and affects multiple parts, you might run into some issues where you have separate parts. So you need to like adjust the scope or combine the parts together into a single part, which you can actually do using the Boolean tool, but that's getting a bit advanced. So I'll stop talking about that. So that's text. Another thing you can do is, can make, for example, a block with the letters cut out. I'll just make a rectangle. So I can do something like this. And you'll notice in cases like this, bit of a drawback is that you can't fully do every letter in the alphabet because a lot of letters in the alphabet have holes in them. So whenever you have a hole, you can imagine you can't make a single part that also includes the hole in the O because it wouldn't be connected to the rest of it. So what you can do is create your block first. And once you create the block, if you then you just get rid of that. Let me do this in a smarter way. All right, so I have my block, and I can either add the text as a boss. So it's kind of sticking out of the block. So you could do something like this. And as you know, you can also do cuts with the extrude tool using the remove function. So you can do kind of like an engraving. So that's just some stuff you can do with the text tool. Are there any questions about the text tool? If not, I'll show you one more tool. And that is that you can actually import files that are not 3D models into Onshape. So let's say I'm trying to make a keychain that's in the shape of a cat. Let's say I'm just looking for something like this, right? I want my keychain in the shape of a cat. So I have this file, for example. And here, the same way I imported like the parts from McMaster or the part from Thingiverse, I can also import an image. So that was the image I just downloaded. And you can see in the second tab, I have that image that I found on the internet. So great, I have this image. What can I do with that? You can actually put that into your sketch. So I created a sketch here again. And now what I can do here, on the tool that's right next to your dimension tool, you see, and for me, there's a drop down. There's insert DXF or drawing or insert image. So what you want is insert image. You can hit that. And when you do, it'll pull up any images that you have in the same part studio. It'll also work for other studio, like you can also find it in other documents, but it's easiest if you just have it in the same document. So you're gonna want to select the image that you have. And then just like the text, you're gonna draw a rectangle. It's a 2-point rectangle. And that'll bring your image into Onshape. And now you might be thinking, what can I do with that? It's not like the image is automatically turned into a sketch entity that I can interact with, right? And while that is true, you can kind of use this to create your own sketch entity. So I'll show you what I mean. Right now, all I have in here really is 4 construction lines, right? I have the outline of a box. All of this stuff, even though it's black and it kind of looks like it's in my sketch, like this isn't real. This isn't anything. It's just for the user, you, to look at. So what we need to do is create something in the sketch that matches what we want, which is this cat. So a really easy way you can do that is using the Spline tool. In most cases, in almost all cases, I recommend you stay away from this tool. Unless you're doing equation-driven curves or something like that, it's best not to use splines. But in this specific instance, when you're designing something, it's pretty casual, you know, just like a hobby, a fun little part that you don't really care too much about, you know, fully dimensioning your splines as long as you know that they're correct. So I know that my image size is 3 inches across because I just constrained the box for the image. So I feel fairly confident, you know, whatever I do with splines, it's going to be fine for my purposes. So we use a spline tool. This might be a new tool for a lot of you. And the way it works is kind of like the line tool, except
I used it at the beginning of the year. It was kind of hard to control.
yeah. So I'll show you. I'll show you like the basic of what a spline is, and then I'll use it in kind of a niche, maybe niche way. So at face value, a spline is like a line, except you can curve it. So I created a spline there. You know, this is the simplest spline. It's just 2 points, and you create it just like you create a line, right? Let me show you that one more time. You have the spline tool. You hit your first point, hit your second point, and then it'll prompt you to keep making points. But if you don't want that, you can just hit escape, and then it'll stop there. So right now, it looks just like a line, right? I've basically just used the line tool. What's different is these guide lines. So these 2 white points, they kind of control how the spline connects these 2 points. So the 2 filled-in points, the 2 blue points, those are the end points. So no matter what, the spline is going to start at one of the points and end at the other one. But what it does in between those 2 points is kind of, there's a lot of freedom. So these 2 guidelines, their purpose is to dictate the initial angle. It kind of acts like a tangent line. It tells the spline what direction it should start moving before it goes out to meet the other end. So you can see as I move this tangent line around, I still have like one continuous smooth curve that connects the 2 points. It's just that the shape of it can basically be whatever I want. It can be like an arc, it can be like an S. I can make pretty much any curve that connects 2 points using this tool. And so you can imagine this is really hard to fully constrain, right? There's basically 4 points that you need to fully constrain just to make this one thing. And so that's why I say that in most cases you shouldn't use it, because it's hard to create exactly what you want. Usually it's easier and better to just use circular arcs and lines. But what we're going to do, instead of dealing with any of that constraining business, we're just going to string along splines to get a freeform curve. And so that's something that splines are really great at, because as you continue to make spline points, they kind of just smoothly merge into each other. So I'll show you what I mean. I have my image here, and I'm just going to start playing connect the dots. I'm just going to click at multiple points in sequence. And as I do, you'll see that the spline traces out the points that I click on. You can see every time I click, the curvature of the entire spline changes slightly. But the more times I click, you know, the more it'll be constrained. The more, maybe constrained isn't the right word, the more closely it'll follow what I want, is maybe the best way to put it. So when you have like a sharp change in curvature, you might need some more points. When you have some longer stretches where it's straight, you probably don't need as many points to get it to follow that curve. But what I'm going to do is just trace this image And when I'm done, what I'll have is a sketch entity. I'll have something that's actually in my sketch that corresponds to the image that I wanted in the first place. I'll go a bit quickly. And so the big thing to think about here, and just keep in mind like the size, scale of what you're working with. If you have too many really small details, those aren't going to come out in the print. If the size of any feature is comparable to the diameter of the nozzle that the material is going to come out of, right? If you're printing with like each deposition is 1 millimeter thick or 0.5 millimeter thick or whatever, any feature that's close to that size is just not going to come out because it's not physically possible to create a shape that's smaller than the thing you're creating it out of. So that's the main thing to be careful when you do something like this with the intention to print it. I'll keep going and wrap around. And to end the spline, what you can do is just click on the point that you started on, and that'll finish it automatically. So what you can see is that everything is blue. Like none of this is fully constrained right now. None of this is even remotely constrained right now. Any of these blue points, I could drag them around, and the whole spline will have to change to accommodate the new position. So if you're designing anything serious, if you're designing like a real part, you can see why this isn't a great thing to use, because it's so easy to completely change the entire geometry just by moving a little point around. For something like this, it doesn't matter, which is why we're doing it. So I showed you this. So this, I can just say I'm done with my sketch. And then just like any other sketch entity, now I can extrude it. It's a bit thicker than I probably want. You can see we've created now the part. It's just like any other extrusion that we do. I can call this a cat-shaped cylinder, right? Prismatic cat. So from here, hopefully you have a few ideas now. You can combine the two ideas. You can try drawing something freehand using the Spline Tool. You can try putting text on it. Just one last thing I'll demo is a matter of making it an actual keychain, right? So you're going to want to modify this extrusion once you're done to include something for the actual key to loop onto, right? You need a loop or a hook or something like that. So the easiest thing you can do is probably just to extrude one, something we're hopefully quite good at now. Also, disclaimer that the size of my part is nowhere near being reasonable for an actual keychain. Let's just say So I can just sketch a little ring like that and bring up that ring. Let's see, what does that like? All right, so yeah, the idea is, this is no different than anything else you've been doing. It interacts the same way with other features. Like you can add things onto it. I could also like combine this with the first thing. Could add a cat, like add some text to it. It's not cooperating. All right, I think I might be having some performance issues just because I might have too many spline points or something like that. In any case, let's see. You can see that there's a lot of things you can do. And it's really just up to you. It's pretty divergent from what we were doing for the past 4 weeks, which was, trying to replicate exactly the dimensions and geometry that you saw in the drawing. Now you're just kind of doing whatever you want to. So that can be fun in its own way. But it's all the demos that I had planned for today.
I was confused. Wait, we're doing a keychain. Like we can do anything on the keychain. Oh, I thought we were doing like a key.
Oh yeah, so basically we're doing anything. No, it doesn't even have to be a keychain, just anything cool that you want to make that you could make on a 3D printer, right? So nothing that's impossible. I guess there's not much that's really impossible with a 3D printer, but the idea is just for these last 2 weeks, you can kind of create whatever you want using the tools that you've learned at this point. I'll give you the rest of this class to start working on the project, thinking about ideas, trying things out. If you have any questions about tools that I haven't showed you, but you want me to show you, like there are a lot of tools here that could be useful that you might not know about. So just feel free to start working on that. Ask me any questions that you have. But in terms of me talking, that's all I have planned for the day. So just get started on the project. Let me know if you have any questions.
I have a question.
Yeah.
I forgot, how do you like upload something from the internet and then make it so that make it on different documents so that you can like actually draw on it and then like connect the dots so you can actually like change it and stuff?
In your part studio, or in your document rather, there's a plus sign, right? And then there's the import function. So this works just like when we were importing like part files. When you're downloading 3D models, you just, instead of a part file, it just happens to be an image file. So just make a note of where you save that image that you want, and then you can import it like anything else in Onshape. And when you do, it'll appear. It'll appear.
But then how do you like change it? Like after you do connect the dots, how do you like change it to a different document?
what do you want to do after you create the spline entity? Are you trying to?
Like, how do you change it to another document, like how I did there? Like, how did you make it so that you can like change it?
I'm not quite sure what you mean by changing. Could you explain?
So basically, after you did spline,
Yeah.
how do you right now have a new document with the cat?
Everything I've done today has been in this single document, right? Like I haven't, like it's all been in this one document that I named Keychain Demo.
No, I'm saying the part studio.
Right, it's all in here. So in the sketch, you know, I created my splines, right? So you're good up to here.
Yep.
So then what's your question?
Oh, and then you extrude it, and then it looks like that, right?
Yeah, then you can extrude it, just
Oh,
like
okay.
anything else.
Wait, can we just draw the thing ourselves?
Yeah, you can use a spline tool to freehand stuff. So in a case like that, I'd say it's a good idea. Like for this project, you kind of care about the size of the overall thing. And when you just make a spline, you might not know what size you're dealing
Can I
with.
like not use the spline for some of it? Like, can I use like the circle tools? Like, because I know
Yeah,
it's easier.
you can link lines and arcs and splines as you please. My only suggestion would be that you create like a box of construction lines and then you dimension the box just so you know that your entire thing falls within the size of the box, right? Like if you know that your box is 3x2.
How big is the box supposed to be?
It's really up to you. Just make it something reasonable, right? If you're trying to make a keychain, then it's probably not going to be bigger than like 2 inches across, right? Because it needs to fit in your pocket and all. If you're making something else, you know, it depends on the application, what you're doing. But you definitely can, you know, have some splines like that. Have lines coming
So
off.
you think the max should be like 2x3 inches?
Again, it depends on what you're doing. 2x3 is not unreasonable for a little trinket that you're 3D printing though.
Can I do 3x3?
Yeah. So just to wrap up on time, next week is going to be our last week. It's week 8 of 8, so that'll be the end of our CAD 2 class. And the goal there is just to have you guys finish up your keychains, and then you can do with those what you please. In terms of what we're doing next week, I'll start off again. I'll just talk about some more 3D printing considerations, and specifically, I'll mention some things that you should look out for in your model design, things like minimum feature width that can affect, for example, like the tip of these ears might be too thin, might not be possible to print them at the resolution of most printers, for example. So things like that I'll talk about. And yeah, with that, we'll just wrap up the class. For today, if you have any last minute questions, I'm here. I guess also think about, next week, for example, if you want to learn about any of these tools or, assembly tools, if there's anything you want to learn how to do in Onshape that you want me to explain, I'd be happy to do that. Just think about it between this week and next week. And at the start of next week, I'll just ask you, if there's anything you want me to show you. Otherwise, that's all I have for you. You can work on this for next week if you want. You also have some time next week to do it as well. So no real homework or anything. Just keep thinking about, any questions, try to come with some questions since it's the last week of the class. Otherwise, thanks for coming, and I'll see you guys next week.